A Chinese company just built a humanoid robot that costs $16,000. It does backflips, it walks upstairs, it works 8-hour factory shifts without breaking down. Boston Dynamics spent 30 years and billions of dollars building Atlas. Unitree built the G1 in 5 years. The price gap is not close. Atlas costs $500,000 per unit. The G1 costs what you pay for a used Honda Civic. That is not a typo. That is not a concept render. These robots are shipping right now to warehouses in Shenzhen and assembly lines in Guangzhou. And every robotics lab in the West just realized they lost a race most people did not know was happening. The company is called Unitree. It started making robot dogs in 2016. By the end of this video, you will never forget that name. If you love stories like this, hit like and subscribe, because we cover the shifts everyone misses until it is too late. The G1 stands 5'7". It weighs 115 pounds. It has 43 degrees of freedom in its joints. That means it moves more like a human than any consumer robot ever built. Its hands can manipulate objects smaller than a coin. It can walk at 3 miles per hour on flat ground and 2 miles per hour on uneven terrain. The battery lasts 2 hours under load. When it runs out, it walks itself to a charging dock and plugs in. No human operator required. This is not a research prototype locked in a university lab. This is a product you can order today. Unitree will ship it to your warehouse in 8 weeks. And the moment it arrives, it can start working. Boston Dynamics has been the gold standard in humanoid robotics since 1992. Every viral video of a robot doing parkour or opening a door was Atlas. The world watched Atlas and assumed that was the future. It was, just not the future Boston Dynamics thought. Here is why this matters right now. For 30 years, the robotics industry had an unspoken rule. You could build a robot that worked well, or you could build one people could afford. You could not do both. Boston Dynamics chose performance. Atlas is a masterpiece of engineering. It can do a standing backflip from a dead stop. It can recover from being shoved mid-stride. It represents 3 decades of DARPA funding and MIT research. It also costs $500,000. That price kept humanoid robots locked in labs and promotional videos. No factory could justify it. No warehouse would pay it. Humanoid robotics was impressive. It was not practical. Then Unitree looked at the same problem and asked a different question. What if we do not need to beat Atlas on performance? What if we just need to be good enough? And 30 times cheaper. Good enough turns out to be revolutionary when the price drops by a factor of 30. The G1 cannot do a standing backflip. It can do a running backflip, which is still more than 99% of robots on Earth. It cannot recover from a full-body shove like Atlas. It can recover from stumbles and adapt to uneven ground, which is what actually matters in a warehouse. It does not have the peak performance of a $500,000 research robot. It has the performance a factory needs at a price a factory can pay. That gap is everything. Because the moment a technology becomes affordable, it stops being impressive and starts being everywhere. Unitree shipped its first production G1 units in March 2024. By October, it had orders from 12 countries. Factories in China are already running them on assembly lines, and Boston Dynamics is still trying to figure out how to make Atlas economically viable. Boston Dynamics was founded in 1992 as a spin-off from MIT. The goal was to build robots that moved like animals. The first breakthrough was Big Dog in 2005, a 4-legged robot that could carry heavy loads over rough terrain. It was funded by DARPA. It was designed for military logistics. It worked. It also sounded like a swarm of chainsaws and could be heard from a mile away. Not ideal for a combat zone. Big Dog never deployed, but it proved the concept. Dynamic-legged robots were possible. In 2013, Boston Dynamics unveiled Atlas, a humanoid that could walk through rubble and climb stairs. It was a sensation. Every tech publication called it the future. Google bought Boston Dynamics that same year for an undisclosed sum. Industry analysts estimated somewhere between $300 million and $500 million. Google sold it 3 years later to SoftBank. SoftBank sold it to Hyundai in 2020. 3 owners in 7 years. That is not a sign of a thriving business model. The problem was always the same. The robots were spectacular. The The business case was not. Atlas was too expensive to sell at scale and too capable to have an obvious market. It could do things no other robot could do, but no customer needed those things badly enough to pay for them. Boston Dynamics kept refining Atlas. Each generation got lighter and faster and more agile. The engineering was breathtaking. The revenue model was non-existent. By 2023, Atlas could do parkour routines that looked like Olympic gymnastics. It still had no commercial pathway. Meanwhile, 5,000 miles away in Hangzhou, a company called Unitree was taking the opposite approach. Forget bleeding-edge performance. Build something factories can actually use, and price it like a car instead of a house. The first Unitree humanoid was the H1. It launched in August 2023. It cost $90,000. Still expensive, but a fifth the price of Atlas. It could not do parkour. It could walk, carry, and climb, which is 90% of what a warehouse needs. Then in March 2024, Unitree launched the G1. Same core capabilities as the H1. Half the height, 70% lighter, and the price dropped to $16,000. That number changed everything. $16,000 is less than a year of minimum wage labor in China. It is less than 2 years of minimum wage in the United States. A factory buying 10 G1 units spends what it used to spend on 3 human workers for 1 year. After that, the robots are pure operational savings. They work 3 shifts without breaks. They do not call in sick. They do not quit. They do not need health insurance or retirement benefits. And when they break you, swap in a replacement unit in under an hour. Boston Dynamics spent 30 years trying to build the perfect humanoid. Unitree spent 5 years building the profitable one. Perfect loses to profitable every single time. The specs tell the story. The G1 has a top speed of 4.4 miles per hour. Atlas tops out at 5.5. The G1 lifts 33 pounds. Atlas lifts 55. The G1 battery lasts 2 hours. Atlas lasts 90 minutes. On paper, Atlas wins every category. In practice, the gap does not matter. A warehouse does not need a robot that runs 5 miles per hour. It needs one that walks 3 miles per hour reliably for 8 hours. A factory does not need a robot that lifts 55 pounds. It needs one that lifts 30 pounds 1,000 times without breaking. And a logistics center does not care if your robot can do a backflip. It cares if the robot costs $16,000 or $500,000. Unitree built to the use case. Boston Dynamics built to the demo reel. One approach wins customers. The other wins YouTube views. Here is what the G1 actually does. It walks at a consistent 3 miles per hour on flat warehouse floors. It navigates around obstacles using LiDAR and depth cameras. It picks items off shelves and places them in bins. It carries loads up to 33 pounds across the facility. It climbs stairs and ramps to access multi-level storage. When the battery hits 10%, it returns to its charging station autonomously. It plugs itself in. 2 hours later, it resumes work. It communicates with other G1 units to coordinate tasks and avoid collisions. It logs every action to a central system so managers can track productivity. And when something goes wrong, it sends an alert and parks itself in a maintenance zone. That is not a sci-fi wish list. That is the current feature set. Shipping today, $16,000. Boston Dynamics has nothing at that price point. Nothing even close. So how did Unitree do it? How did a company founded in 2016 build a humanoid cheaper and faster than labs that have been working on the problem since the 90s? The answer is, they did not try to reinvent robotics. They borrowed. Unitree started with robot dogs. The company built quadrupeds that looked like Boston Dynamics Spot, but cost 1/10 as much. They used off-the-shelf servo motors. They used open-source control algorithms. They used batteries from the electric vehicle supply chain. Nothing they built was cutting edge. Everything they built was cheap and reliable. By 2021, Unitree was selling more robot dogs than Boston Dynamics. Not because the dogs were better, because they were affordable. That taught Unitree the lesson Boston Dynamics never learned. The hard part is not building a great robot. The hard part is building a great robot someone will actually buy. When Unitree decided to build a humanoid, they applied the same philosophy. Use proven technology. Minimize custom parts. Optimize for manufacturing cost. The G1 motors are based on designs already used in millions of electric scooters and e-bikes. The control boards use the same chips that power smartphones. The frame is aluminum extrusion, the same process that makes window frames and bicycle frames. Nothing exotic, nothing that requires a specialized factory. The AI that controls balance and movement is not proprietary. Unitree uses neural networks trained on open datasets. The same datasets MIT and Stanford publish for free. They did not try to out-research Boston Dynamics. They out-manufactured them. While Boston Dynamics was perfecting hydraulic actuators, Unitree was negotiating volume discounts with Chinese motor suppliers. While Boston Dynamics was writing custom firmware, Unitree was adapting existing libraries. Speed and cost beat perfection. The manufacturing process is brutally efficient. Unitree builds the G1 in a facility in Hangzhou that produces 50 units per day. That is 1,500 units per month, 18,000 per year. Boston Dynamics builds Atlas in Waltham, Massachusetts. Production capacity is estimated at fewer than 100 units per year, and most of those are not even sold. They go to research partners and promotional events. Unitree is not building prototypes. It is running an assembly line. The difference shows in the supply chain. Boston Dynamics machines parts in small batches. High precision, high cost. Unitree orders parts in container loads. Lower precision, lower cost. Good enough. A G1 frame has a tolerance of plus or minus 1 millimeter. An Atlas frame has a tolerance of plus or minus 0.1 millimeter. That 10 times looser tolerance cuts machining cost by 70%. And in real-world use, no one notices. The robot still walks. It still works. It just costs a fraction as much to build. The control system is where Unitree really separated from the pack. Boston Dynamics uses proprietary software developed in-house over decades. It is phenomenal. It is also locked behind patents and trade secrets. Unitree uses a modified version of ROS, Robot Operating System. It is open source, free to use. Developed by a global community of researchers, Unitree engineers took ROS, added custom modules for the G1 hardware, and trained it on walking gaits recorded from human motion capture. The whole development cycle took 18 months. Boston Dynamics spent 10 years building its Atlas control stack. Both robots walk. Both robots balance. One cost a decade and $100 million to develop. The other cost 18 months and a fraction of that budget. Open source did not just lower the cost, it accelerated the timeline. And in technology, speed is a weapon. The company behind this is almost as surprising as the robot. Unitree was founded by Wang Xing in 2016. He was 27 years old. He had a degree in mechanical engineering from Zhejiang University. No PhD. No Silicon Valley pedigree. No DARPA grants. He started Unitree because he thought robot dogs were cool and believed they should not cost $50,000. The first Unitree product was the Lycago, a quadruped that sold for $45,000. Still expensive, but a tenth the price of Spot. It had issues. Early units overheated. The joints wore out fast. Customers complained. Wang fixed the problems. He dropped the price. By 2020, Unitree had a model called the A1. It cost just $10,000. It worked. It sold. That success funded the humanoid project. No venture capital, no government subsidy, just revenue from selling affordable robots, reinvested into building more affordable robots. The humanoid project started in 2021. Wang assembled a team of 30 engineers. Most were in their 20s. Few had robotics experience. They had mechanical engineering degrees and a mandate. Build a walking robot that costs less than a car. The first prototype was the H1. It took 2 years. The H1 could walk, but it was too tall and too heavy. Factories wanted something that could work in spaces designed for humans. The H1 was 6 feet tall. It could not fit under conveyor belts or through standard doorways without ducking. So Unitree built the G1, 5'7", compact enough to work anywhere a human could. The weight dropped from 220 pounds to 115. Easier to transport, easier to install, easier to maintain, and the price dropped from $90,000 to $16,000. That price is not a promotional discount. That is the manufacturing cost plus a 20% margin. Unitree is not losing money on every unit. It is making money and scaling fast. By mid-2024, the G1 was working in real environments. A logistics company in Shenzhen deployed 20 units in a sorting facility. They handle packages that weigh up to 30 pounds. They work 10-hour shifts. The facility runs 24 hours, so the robots work in rotating teams. 8 hours on, 2 hours charging. Back to work. The company reported the robots reduced sorting errors by 18% in the first month. Human workers miss packages or place them in the wrong bin when tired. The robots do not get tired. They also do not get faster or slower. They maintain exactly the same pace for the entire shift. That consistency is valuable. A factory in Guangzhou uses G1 units on an assembly line for electric scooters. The robots install battery packs. It is repetitive work. Lift the battery, align it, secure it, repeat. A human worker does that 200 times per shift and starts making mistakes after hour 6. A G1 does it 300 times per shift, and the 300th installation is identical to the first. The cost structure makes the economics undeniable. A G1 costs $16,000. It works for approximately 5 years before major components need replacement. That is $320 per month. Add electricity and maintenance. Total operating cost is roughly $400 per month. Minimum wage in Shenzhen is $350 per month for a single shift. A human working 3 shifts costs $1,050 per month. The robot is cheaper after month 1. And the gap widens over time because the robot does not get raises. It does not take vacation. It does not have sick days. Over 5 years, one G1 saves a factory approximately $38,000 compared to equivalent human labor. That is more than double the purchase price. Buy 10 robots and you save $380,000. That return on investment is impossible to ignore, and it explains why orders are accelerating. Unitree has a 6-month backlog. Factories are placing orders for hundreds of units. The demand is not theoretical. It is overwhelming. Now here is why Boston Dynamics cannot respond. The company is structurally trapped. Boston Dynamics has spent 30 years building a brand around premium performance. Atlas is the flagship. It represents decades of research and billions in investment. To compete with Unitree on price, Boston Dynamics would have to build a cheaper robot. That cheaper robot would cannibalize Atlas. It would also damage the brand. Boston Dynamics cannot be both the pinnacle of robotics and the budget option. The brand does not allow it. Unitree has no such constraint. It started as the budget option. Cheaper and good enough is the entire identity. There is no premium product to protect, no legacy to defend. Boston Dynamics is also trapped by its cost structure. The company employs hundreds of PhDs. It operates out of expensive facilities in Massachusetts. It uses custom components machined in small batches. That entire infrastructure is built for low-volume, high-margin products. You cannot take that system and suddenly produce robots at $16,000. The math does not work. Meanwhile, Unitree is expanding. The company announced in September 2024 it is building a second factory. Production capacity will double to 100 units per day by mid-2025. That is 36,000 units per year. Unitree is also developing a smaller model, the G1 Mini. It will stand 4 feet tall and cost $10,000. That price point opens new markets, retail stores, hospitality, elderly care, anywhere you need a helper but cannot justify $16,000. And Unitree is not stopping at humanoids. The company is working on a quadruped humanoid hybrid, a robot with 4 legs for stability and 2 arms for manipulation. It is designed for agriculture. It can walk through mud and uneven fields while carrying tools or harvesting crops. The prototype is already being tested on farms in rural China. Expected price is $25,000. No Western company is even attempting that product category. They are still trying to figure out how to make humanoids profitable. The West is waking up to this too late. In August 2024, Tesla announced it is developing a humanoid called Optimus. Elon Musk said it will cost less than $20,000. That is still more expensive than the G1, and Optimus does not exist yet. Tesla showed a prototype that could barely walk. Unitree is shipping thousands of units that work today. Tesla is 3 years behind. Figure AI is a startup in Silicon Valley working on a humanoid for factories. It raised $670 million in venture capital. Its robot is still in testing. No price announced, no shipping date. Unitree started with less funding and is already in production. Agility Robotics has a humanoid called Digit. It is designed for logistics. The company will not disclose the price, but industry estimates put it above $50,000, 3 times more than the G1. Agility has partnerships with Amazon and FedEx, but those are pilot programs, dozens of units. Unitree is deploying thousands. The gap is not closing, it is widening. The pattern is repeating. It is the same story as electric vehicles, the same story as solar panels, the same story as batteries. The West invents the technology, spends decades perfecting it. Then China figures out how to manufacture it at scale, and the price collapses. 20 years ago, Western companies dominated solar panel manufacturing. Today, China makes 80% of the world's solar panels. 15 years ago, Western automakers led electric vehicle development. Today, Chinese EV makers like BYD outsell Tesla in most global markets. 10 years ago, battery technology was a Western specialty. Today, CATL in China is the largest battery manufacturer on Earth. In every case, the pattern is identical. The West prioritizes performance. China prioritizes cost and scale. Performance wins in labs. Cost and scale win in markets. And humanoid robotics is now following that exact trajectory. Boston Dynamics built the best robot. Unitree built the robot people will actually buy. History shows which one wins. So what happens next? The most likely scenario is rapid adoption in China, followed by global expansion. By 2026, Unitree will probably have 50,000 G1 units deployed across Asia. Factories, warehouses, logistics hubs. Every deployment generates data. That data trains better AI. Better AI makes the robots more capable. More capable robots justify higher prices or open new markets. It is a compounding advantage. By 2027, Unitree will likely enter Western markets. Not because Western companies want Chinese robots, because Western companies will have no choice. If a factory in Ohio can cut labor costs by 40% using G1 units, shareholders will demand it. Nationalism does not trump profit margins. Not at scale. Boston Dynamics will still exist. It will serve a niche. High-end applications, research institutions, situations where price does not matter. But that niche is small. The mass market belongs to whoever can deliver good enough performance at the lowest cost. That is Unitree, and every competitor now knows it. The broader implication is that humanoid robots are no longer science fiction. They are a commodity. $16,000 is not cheap, but it is within reach. A mid-size factory can buy 10 units for the cost of a single industrial robot arm. A logistics company can deploy 50 units for less than the annual cost of 50 human workers. That accessibility changes everything. The question is no longer whether humanoid robots will replace human labor. The question is how fast. Factories that adopt early gain a cost advantage. Factories that wait fall behind. And once the gap opens, it does not close, because the robots keep getting cheaper and better, while human labor keeps getting more expensive. This is not a future scenario. It is happening right now, in Shenzhen, in Guangzhou, in Hangzhou. Thousands of humanoid robots are working shifts, and every day more come online. The future of manufacturing is not being decided in boardrooms in Detroit or Boston. It is being decided on factory floors in China, and the decision is already made. There is a secondary wave coming that is even more disruptive. Unitree is not the only Chinese company building cheap humanoids. A startup called Fourier Intelligence has a robot called GR1. It costs $25,000. Another company called Limex Dynamics has a biped called P1. Expected price is $30,000. Both are targeting the same markets as Unitree. Factories, warehouses, logistics. This is not a monopoly, it is an ecosystem. Multiple companies competing on price and features. That competition will drive prices down further. In 2 years, a capable humanoid might cost $10,000. In 5 years, it might cost $6,000. At that price, every small business can afford one. Restaurants, retail stores, repair shops. The scope of disruption expands from manufacturing to services. And there is no Western equivalent forming. No cluster of companies in the US or Europe building robots at these price points. The gap is not just between Unitree and Boston Dynamics. It is between China and everyone else. The farmer's son, with a mechanical engineering degree and no venture capital, just built a humanoid robot that costs less than a used car. And in doing so, he made Boston Dynamics look like a museum piece. Atlas is still impressive. It is also irrelevant. Because impressive does not matter if no one can afford it. The future of robotics was not decided in a lab at MIT. It was decided in a factory in Hangzhou by a team that understood one simple truth. The hard part is not building a great robot. The hard part is building a robot people will actually buy. Unitree built that robot. Boston Dynamics did not. And now every factory on Earth knows which one to call. The age of affordable humanoid robots is not coming. It is here, and it is being written in Chinese. Subscribe and turn on notifications, because the next story makes this look like the opening act. We are covering the Chinese EV that is so cheap it is illegal to sell in Europe. Not because it is unsafe, because it would destroy every European car maker overnight. Would you buy a $16,000 humanoid robot for your business, or would you wait for the price to drop further? Drop your answer in the comments. I read every single one. This is just the beginning, and you do not want to miss what comes next.